All right, ladies and gents, in this video we are going to go over the standard molar heat of formation. So you'll see this molar heat is our delta H. Formation means exactly what it sounds like, how much energy it takes to form 1 mole of our compound from its elements. So basically what Mother Nature does. All right. If we're going to standardize it, you're going to see that little degree sign up here, and that little degree sign means it's going to be at a temperature of 25 degrees Celsius. I know that STP for gases is going to be at 0 degrees Celsius, but basically scientists were like, I'm not going to work with really cold conditions for our solids because they're going to be solid there and here. So we're going to talk about that at room temp. So you're going to see a new standardized temperature there. Now, molar heats of formation have been determined by scientists, so it's nothing that we would actually have to calculate and figure out. But we do need to know how to basically prove that it happens and to be really careful with what it says on the tables. So what you'll see is there's usually an appendix that goes with this. We use the one on page 862 of the Modern Chemistry textbook, but you'll see that there are various heats of formation listed for water. There's a different one for steam. So when you have combustion reactions, you got to be careful that you don't use this negative 285.86 kilojoules here. For the formation of salt, for SO2 gas, etc., etc., etc. So you see these values that we will later on use in Hess's law in order to determine what the delta H of the reaction is going to be. All right, you'll see that the heat of formation for any type of element is going to be 0 because the elements exist in a certain quantity here on Earth. They do not have to be formed. You'll also see that the negative value that's going to be in front of the delta H of formation is going to basically show that these are all exothermic. They are more stable as compounds than they are as their free elements, which is why we have compounds in the first place, okay? The things joining. So this is an example of some standard molar enthalpies. You'll see that diamond in the graphite form is 0, but carbon in the graphite form, sorry, not diamond in the graphite form, carbon in the diamond form is going to take some energy. Where your methane, your ethane, propane, butane, so changing your different carbons amounts, so you're going to see that they take more and more energy. The larger the substance, usually it's going to have more and more energy inside of it. Ethanol, sucrose, etc., as you travel down. And notice again, hydrogen is going to be 0 because hydrogen exists in nature. All right, so what are we going to look for when we are doing our heat of formation equations? Basically, what we're looking for is an equation where a compound is made from its elements. So we have to be careful on how we represent our elements, because remember, we have 7 diatomic elements that we need to know. They are Brinkelhoff. So Br comes into, I comes into, N comes into Cl, H, O, and F. So if we are writing a formation equation for water, okay, how do we make water up from its elements? I need 2 hydrogens and 1 oxygen. So I use H2 and I use half of an O2 molecule. That is my heat of formation equation for making water. And then I can look that up. Water in the liquid form is negative 285.8 kilojoules. How do I make up salt? How do I write NaCl as a formation to form it, to synthesize it, to make it from its elements? Well, Na plus half a Cl2. That gives me NaCl. S plus O2 gives you SO2. So a formation equation is used in order to figure out how Mother Nature goes about putting these things together. All right, so let's write the formation equation for sucrose. Sucrose is going to be C12H22O11. So how do I form that? C12H22O11 from its elements. Well, I'm going to need 12 carbons. How many H2s am I going to need? If I have 22 of them, I'm going to need 11 H2s, okay? And I am going to need 11 oxygens. Oxygen is diatomic. So what am I going to have to put in front of my oxygen? In order to get my 11, I'm going to need a 5.5. All right, so the formation equation for this is going to be 12 carbons plus 11 hydrogens and 5.5 O2s. And then I would look up on a table, on an appendix somewhere, what the heat of formation is for sucrose. And that is negative 2,221.2 kilojoules per mole. All right, so for every one of these, that's how much energy is released by forming those things together. All right, so you'll see over here, sucrose is C12H22O11, and I need 12 carbons, 22 hydrogens, and 5.5 O2s to make C12H22O11. And you'll see that this value right here would then be used in Hess's law. Okay, so this will be applied in Hess's law when we figure out what the delta H for the reaction is going to be. All right, a chemist usually figures out how much energy a reaction is going to either add or gain to add to the surroundings or absorb from the surroundings in order to make sure that what they make isn't going to melt the container it is in. And that is the heat of formation.